Okay, so good day, everyone, and welcome to the Women in Data Science Trinidad and Tobago February Datathon sessions. I am Dr. Addison, and my team and I are hosting a session today with our featured speaker, Miss Sarah Ostermeier, who's going to talk about finish training your ML model, what next? Now, before we actually jump in, I'd like to remind persons, for those of you who may not have known, or for those of you who are already in the process, these Datathon sessions are in support of not only awareness of data science and supporting women in the field, but also for a global Datathon, which is being hosted on Kaggle. And this is the WiDS 2023 Datathon Challenge based on climate change. So it started on January 4th, and the closing date is March 1st. Those of you who still would like to jump in and see what that's about, you can actually follow the link provided, and you can get an idea of how to go about entering the challenge. So we look forward to more of you being involved and using your skills that you gain in these sessions to be able to analyze the data sets and get some machine learning insights. In terms of our team, for any persons new who haven't joined us for our other February sessions, we are the Trinidad and Tobago team, and we host independent events associated with the global team, the global WiDS team, which is through a conference hosted by Stanford University. If you would like more information on the events that we have hosted and we are going to host in March, feel free to visit our website at widstt.org. Just to let you know, this is our final Datathon session for February because we had 3 so far. This is the 3rd. But in March, when March starts, we will have 2 less technical sessions, a spotlight talk on AI applications in agriculture in the Caribbean. That will be March 4th. And then we will have a fireside chat, which is a bit of an informal panel discussion with. Right. And for those of you who are actually interested in the challenge, once again, you can actually go on the website. You have to have a Kaggle name. So you have to go on Kaggle, first of all, and then you can also visit the widsconference.org website to be able to get more information on the challenge. Feel free to, as I mentioned before, visit our website, the widstt.org website, if you would still like to participate. It's actually coming to a close soon in terms of being able to take on any team members. But of course, if you go on the Kaggle page, you will see other teams who may be able to take on team members to be able to jump into the competition. And if you have any questions on our sessions or anything else related to data science and our talks, feel free to visit to not only visit our website, but also contact us via email. Right. So today's session, we had our icebreaker question. So this is based on what is your current field of career or study. So I was able to give you all the link to go to that to be able to put in your answers. So let's see what person said. I will just navigate to the page quickly and we can see what the answers were for that. Right. So is everyone seeing my screen?
Yeah.
Yes. Okay. Excellent. Right. So I'm seeing that we have persons who are involved in geoscience, data analytics, electrical engineering, computer engineering. Wow, data engineer, data science, machine learning ops. Right. So we have a lot of data scientists in the room today, which is really great because Sarah has a great interactive talk planned for us based on not only the machine learning aspects, but also how do you take that in the real life context and make it useful. So I will just jump back into the slides. Is everyone still hearing me and seeing my slides? Seeing my screen?
Yeah. Can you hear me?
Yes, hearing you will.
Okay, my headphones are broken, but I'll try and fix them now.
No problem. If you could just mute yourself in the beginning so we won't get any feedback, and then
Yeah,
you
sure.
can always unmute. No problem.
Oh yeah, I'll mute now.
Mute yourself.
Okay, so in today's workshop, I would like to introduce our featured speaker. And before I do, let me just show you the agenda of what she'll speak about. She will give you some insights on responsible model reporting. maintaining model performance over time, ensuring the model works for everyone it impacts, and other aspects that will be useful to, as I see, a lot of you all are very ingrained in the data science field already, so you can actually see that she will give you some great insights moving forward. So without further ado, our speaker is Miss Sarah Ostermeier. She's a field data scientist at Arthur AI in the United States of America. So I would just like to give Sarah the floor to give you all a bit of a background about herself. So Sarah, would you like to tell them about yourself and your background in the field, and how did you get into it?
Yeah, sure. So I am a field data scientist at a company called Arthur AI. So that company is a model monitoring company. We're a startup. We're based in New York. And basically we work in the ML operations space. So what we're doing is going out to mostly enterprise customers, working with them to use our product and make sure that they are monitoring their models over time, also making sure that their models are fair and somewhat explainable, or at least providing tools to do that. So that's a general idea. My role is to actually reach out directly to our customers, to work with them, and really help them to understand how to kind of go about these operations, because it's all a very brand new field, especially in this space of monitoring. So that's kind of where I am now. My background was a little bit circuitous. I started actually with a bachelor's degree in neuroscience. And I was working in neuroscience research for a while before I went back to grad school and did my master's in computer science and machine learning. And then after doing a little bit more kind of combination machine learning and neuroscience research, I kind of landed in this tech startup space. Yeah, that's about it.
Excellent. Well, that's a very colorful background you have there. So we're happy to have you have expertise in all different science fields. And without further ado, I would just like to say, I will give you the floor now to take it over and take it away and let us know about finished training your ML model and how to go about that.
All right.
So I will stop sharing and the floor is yours.
Go ahead and share my screen here. All right, can everyone see the first slide here?
Yes, we can.
All right, awesome. So yeah, I'm going to start by kind of going through some of the concepts behind this, and then we'll get into a notebook and kind of see some of this in action afterwards. So yeah, feel free to interrupt if you have questions. I'll probably try to pause and ask for questions as well, but if I don't, don't worry about asking.
Cool.
Awesome. So I'll get started here. So the main thing that I kind of want to get into is this sort of idea of data science theory versus reality. And what we learn in school is kind of this theory, this idea of how things should work in kind of a somewhat more idealized setting. And then in reality, machine learning models and any type of data science model in production faces a much different scenario. So, you know, in sort of the theory space, you have this idea that you've got a problem that you've got to find somehow, something you're trying to solve for, some target variable. You load your data, you do some experimental data analysis, you do some kind of data preparation, maybe feature selection, maybe feature engineering of some kind. You split up some training and testing data, you do all your model development, and then you do some model scoring based on that sort of static test data set. And you save your model and you're all set. That's kind of all we really think about when we're sort of doing this stuff in that more confined setting. But in reality, things look a lot different. You've got this whole machine learning system around your actual machine learning code. So in this image here, you know, that machine learning code, all of that work we did on that theory side is in that little orange box. And there's everything else kind of in the system around it, just to make that all function in kind of a live system. And then outside of that, there's the context, there's the model context, the real world that this model is living and working in. And so that model context is not quite as static as that training set that we train the model on. It's changing over time, things are moving around, and our model needs to keep up with all of that to really be effective. So kind of getting into this idea of how models work in a production lifecycle, this is kind of the model that I like to use to explain it. So we start with this problem definition. And you notice we kind of go in a circle. We end with the problem definition as well. And I think that's the main thing that really differs between sort of the way that we tend to learn this linear approach kind of in theory, or when we're trying to work in the classroom or in academia. And then in practice, it ends up being a little bit more of a cycle. So you're doing sort of some curation of your data set, you're doing data preparation. So all of that same process, just more dynamically. So you do your model development, you do all that fun part, and then you're going into this full model evaluation, sending your model into production. And from there, in this production life cycle, you've got to be monitoring your model. It doesn't end once you've deployed. You have to keep track of what's going on. And more likely than not, eventually that model will have some kind of a problem. Often it's just that it needs to be retrained, or sometimes something in the world changes drastically enough that you really need to go back and reevaluate the problem that you started with and figure out if you need to make some major changes to that model. And then you kind of start that cycle over again. So for this conversation, I'm not going to be talking about this whole model lifecycle in production. I'm going to focus on just a few parts, like we mentioned at the beginning. So the first part is just doing sort of a more thorough model evaluation once you've trained your model. Then we'll go into sort of how you report those insights from that evaluation, or any other insights you have for your model, and do that in a responsible way. Then I'll go on and talk a little bit about monitoring and maintaining performance of your model, and finally evaluating that model's impact on the world, or on people that are affected by it. So those two parts, that reporting the insights and evaluating the model impact, are really especially related to this model context. How is your model working in the world? So that's going to be kind of a focus here as well. Any questions on this sort of model life cycle before I move on? Okay. So just to kind of set up the problem here, let's imagine we've just developed this amazing weather forecasting model, like a lot of you are doing for the Datathon. Maybe we've tested it on our test data and it's getting great RMSE scores, and we're really excited to get this into production, get it moving so that it can work its wonders in the real world. So the question is, what are the next steps? What do I do now? And the most important thing to do immediately here is start by doing this very thorough evaluation of your model. And I think in the last talk, you did do some fair amount with evaluation. So I won't go over the same stuff that you've kind of already discussed, but I'm going to be talking about a couple of other things here. So the first thing is, checking scores on your test data. That is important to do, but it's also just the first step. So you should be asking these questions kind of as you're doing model development overall, but you want to be asking, making sure you're using the right metrics for the problem that you're solving. And really that means, do they make sense in the real world context that your model will be working in? So just thinking really hard about what metrics you're using to decide on this. And then if this is a regression task, are you accounting for like the distribution of your target variable? Like let's say you have very, very, very few like high valued features high valued outputs in your training data. So whatever the target variable is, maybe you have just like most of that is really low values and very small number of high values. And if that distribution is changing in your training data or in your test data, in your real world data, what are you going to do? Are you accounting for that? And the same is true if it was a classification task. You'd want to be accounting for like class imbalance and making sure that you're like coming up with metrics that are actually accounting for that. And just to kind of make this a little bit more concrete for an example, if we imagine maybe the real world use case of this weather forecasting model, maybe the goal is to predict anomalous extreme weather events. And so in this case, it's especially important that your model performs well in those rare anomalous cases. And it's actually less important for it to perform well at predicting kind of normal weather. So in this case, you might have to select or maybe even design an evaluation metric that weights those anomalous cases more heavily. And that would be the best way to really understand how well your model is performing in the world in the cases that are the most important in the world. So it kind of comes back to this idea of bringing the real world context back into the data science. And so a little bit more on this is just considering how consistent your test data is with the data that you expect your model to run into in the world, right? Do you expect changes in your data over time? Is there newer data that you maybe could be using to actually test your model on? And are there any other differences that you might expect between the test and prediction data? Like, is there something that might be changing? And so based on kind of how you think about all of these questions and whatever answers you have to them, you want to sort of design whatever your evaluation or your test data set is accordingly. So this does kind of come back into the earlier phases of model development, but as you're figuring out what to use as your test data, you want to make sure that it thinks about all these things. So if you know that there's change happening over time, you might want to make sure to use like a later slice of your data as your test data set relative to the training data, so later in time. And then the other thing to do is evaluate your model on different segments of interest. So when you're looking at your model, there might be particular slices of your data that might be important to look at, or that you expect might be different even in terms of their performance, or just qualitatively different. So for this type of climate model, we might think about things like geographic regions. How does your model perform in different locations? The time of year, does it perform worse during like certain times of year maybe, or just maybe it doesn't have as much data from certain areas or times of year? If you were looking at sort of more human related data, you'd of course also want to be looking at different demographic groups, how your model performs across groups to make sure that it is fair. And I guess actually before I go on, are there any questions on this sort of evaluation section? Okay, I will move on. So finally, kind of taking all these things that we've looked at now, how do we report our model insights? And a big part of this is actually convincing other people that your model is useful and safe. It's harder than you might realize too, if you're kind of used to working in maybe a tech or data science setting. If you do happen to be doing a lot of data science in maybe a more conservative industry, or just in a place where people aren't used to using machine learning models, it can take a lot to convince people that this new model that you've developed is actually going to work, and that it's safe, and that they can trust it. So this part gets really important in a lot of those real world settings. So the real idea, the idea is that you want to be responsible about it. You want to make sure to really report the full performance, the insights, and even the weaknesses of your model, and make sure people understand when it works well and when it might not. So the ideas here, I'm going to kind of go through these each separately, but model transparency. Do people kind of feel like they understand something about how this model works? Describing that model performance holistically. So that's kind of going through all of those evaluation type approaches that we talked about. And then highlighting really what the model can generalize to and what its limitations are. So having a model that's like completely transparent and everyone understands everything about it is usually either impossible or impractical for ML models. So we don't, that's a little more than we can reasonably expect. But it is good to be able to describe what data is going into the model. So when you're explaining your model to someone, you want to make sure they understand what data is coming in, what's it for, why is it there. That's where I think the last session from last week that kind of went into feature selection gets important. You maybe would want to, in certain cases, justify why you're using specific features, and so minimizing the number of features that you're using can be helpful here. Especially in making the model a little bit more understandable. And then just understanding, you want to sort of show in any reporting you're doing what the model is doing and give some idea of how it works. Obviously, if you're talking to a non-technical audience, they might not understand everything about how your model functions, but you want them to have some sense of it. And then, of course, there are model explainability tools that can be utilized where appropriate. So there are times where these are great to use, and there are times where I think they can make things a little bit more confusing, but talk a little bit more about that here. So yeah, these explainability tools, if you've ever heard of these before, the most common ones are called SHAP and LIME. And so these are tools that basically take take any one of your samples, and they perturb it. They change little things about each sample of data, and they see how the model output changes whenever they do that. And so with that approach, they can kind of get some idea of which of your features are the most important to your model. So this is fairly similar to some of the feature importance techniques that you went through last week. So I didn't include this in the notebook we're going through later, but if you are interested in making use of these explainability tools, I recommend SHAP and LIME. They're probably the most common and easiest to use. I will note, like, these can be a little bit confusing and sometimes even misleading at times. So I do recommend being careful how you use them. And even sometimes I think that the visualizations that we get from SHAP can be a little bit confusing. Like, I have a fairly good understanding of how SHAP works. And when I look at these plots, sometimes I even get confused. So I think when you're using them to explain models to others, you do have to make sure you really understand them well and have taken the time to learn what these explainability methods are. But yeah, if you're interested, definitely look into these. And then the next part of this is just making sure to describe model performance holistically. Even if it's not good news, you still want to make sure that you provide, complete information here. So everything you check during model evaluation, reporting performance, of course, across data segments like we talked about, and then just making really good use of visualizations to kind of meet your audience where they are. Not everyone is going to be as familiar with your model as you are. In fact, probably no one is. So, use visualizations and use them well. Get familiar with the visualization tools, kind of, if you're using Python or R or whatever ones that are kind of fit for you, get used to using those tools and learn how to really use them in a way that make them, the visualizations understandable to people.
Sarah, there's a question for you before you move on.
Oh, yeah, absolutely.
Helen wants to know, how do you explain your model when SHAP is a black box?
Yeah, that's a great question. Yeah, SHAP is a black box. How do you explain it? The way that I guess I explain this to my customers, I do get this question a lot because we make use of SHAP in my company's product. These explanation techniques, both SHAP and LIME really, they give you an explanation for your model. They don't give you the explanation because there is no the explanation. So I almost think of SHAP and LIME as almost like a person you might be talking to. And it sort of like provides the language for your model. So if I walked up to a different person and asked them to explain why they did something, they'll give me some kind of explanation. And they're a black box. I don't know if that person is telling me the truth about why they made that decision that they made or did something they did. But they're probably telling me to the best. If I trust them, they're telling me to the best of their ability, right? They might not necessarily have access to that information. So SHAP and LIME are kind of like your tool for talking to your model. You're asking, well, can you give me some insight as to how you made this decision? And SHAP is helping your model to do that. It's not going to give you that full transparency. Kind of like I talked about, full transparency for most ML models is almost impossible. That's where I think we talk about like accountability, explaining the inputs, the outputs, what the model is doing, making sure we have robust models. I don't think that those explainer tools can ever really make up for, just being responsible about how we develop models. Does that help? Or at least someone answer the question?
Yes, Helen said thanks in the chat.
Okay, awesome.
Yeah, go ahead.
Great, I'll move on. Yeah, so the other thing you want to try to report on if you're explaining your model is generalization and limitation. So, that really depends a lot on what your model was trained on, what it was tested on. What can you really sort of verify it will be good at handling? You want to kind of explain those limits. And so that also would include sort of identifying if there's certain segments of data that are underrepresented in your model. So, maybe in this climate model, we did not get much data from Antarctica, for example. We might want to note that if we were reporting this, saying, okay, this is not going to be valid for certain regions of the world. The other thing is just, so how do you expect the model to generalize? Do you expect it to generalize to future data, to different geographies, to segments, kind of like what I talked about? When might it fail? And what can this model tell us about the world, and what does it not tell us? So this is going to depend a lot on like specifics of what your model is doing, but it's giving you an output prediction, and kind of like we talked about with the explainability, we can use these types of tools, explainability tools, to give us some insight into what's going on. But a lot of times, because our models are often black boxes, they don't tell us too much else about the world other than just whatever exactly they were optimized to do. So being really transparent about that is also helpful. Okay, before the next section, are there any more questions? Okay. So the next part here is just how can we actually maintain model performance over time? So this is where we get into model monitoring. And just kind of as a little bit of a caveat, if you're sort of training a model on your own in sort of, a more isolated setting, it's very hard to actually execute model monitoring without sort of being in, a larger system where that's set up. But I'll still talk about it. It's definitely something that's important to think about and be aware of, and just know that you need to track and really, retrain your models if they're being used on live data. So the first concept here is data drift. So the model that we have, we're training on sort of a snapshot of data, but then we send that model out into the world, and it is dealing with this really dynamic changing system. So that means we have to really continuously track that model and figure out when it gets to a point where the world has changed so much that it's just not keeping up. So we've got to track our model and update it if needed. So maybe retrain, but also there can be times where the world changes so much that you actually have to make significant changes to the actual model. And so then whenever that happens, of course, you're updating and you're redeploying the model into production. And so this kind of creates that cycle that we're talking about earlier in tracking this data drift. Like I said, when you do have this scenario where the world is changing a lot, your model can drift in, or the data drifts, your model can end up just completely failing. And I've seen this even happen with customers that are like big companies that have tons and tons of models that are running and making decisions in the world, and they haven't been really tracking the performance of those models or whether the world is changing. And you see the models just completely failing after a few months sometimes. So it's really important to be tracking this. And of course, models make decisions in the world. So plenty of banks now use them to decide who gets loans or decide if, your card transaction was fraud. So these are really being used in impactful ways. And so model decay is a really important thing to pay attention to, because it really can impact people in bad ways if it fails. And so just to get, again, a little more concrete into this climate model we're talking about, we do actually know that like the underlying data is changing over time, right? We know that climate change is happening. That's sort of the point here, right? So if we're using this model to like make predictions about predicting extreme weather or anything like that, it's really important that we don't let this model degrade over time, because it definitely will if we just sort of leave it. So if we were going to be putting these models, that you're working on for the datathon into production, we would want to be making sure to really be tracking them and seeing when they need to be retrained, because that would be something that we'd probably have to do frequently. And so there's kind of a cycle to this, but what it means is to really watch out for reductions in performance. And in some cases, just significant data drift. If a lot of times in production, people don't actually have access to performance metrics because they don't have ground truth data coming in very quickly. So in those cases, you have to kind of watch the data and make sure it's not changing a lot, and let that drive when you retrain or update your model. So then the other part of that, though, is that you can't just model your overall model performance. You also need to be looking at different segments of your data, like we did in the evaluation. So looking to see if there are particular geographies that might be failing, or certain times of the year where their model is failing, and making sure to update our training and validation data so that we can then retrain with more data from those segments. And then just making sure that the model is actually performing well with respect to whatever the model's purpose is. So if we've got, a model that is meant to be, predicting extreme weather, maybe we want to make sure that it is actually telling us at the right times when we need to do that. If it tells us, well, there's extreme weather coming in 2 hours, maybe no one can plan for that, right? So we'd want to make sure that whatever the output of the model is actually serving the model's purpose, and that it's effective at that we're actually able to act on whatever the model's output is, and that whole sort of system and context that we're working in is functioning. Otherwise, we might need to change our problem definition or change the way that our model is working. And then, of course, just updating and retraining the model according to kind of all these considerations. Okay, so before the last section, are there any questions about this monitoring and drift element here? Okay, I'll continue then. So yeah, the last part is just about evaluating the impact of a model in the world. So it's especially really making sure that the model works for everyone that it impacts. So this is really bringing that human element into the context here. Any model that is running in production is affecting people in some way. If it's an impactful model, it's going to be in fact impactful on people. So it's really important to make sure that we are treating people fairly, that it's good for all of the people that are affected by it, not just some of them. So get into a little bit of that, but the whole idea here is accountability. So can we accurately describe model limitations? It's important to know if your model is not performing well for certain groups, or even certain geographic regions. And while we're going through this process of model development and evaluation, we need to make sure that we can show who and what the model impacts. So sometimes there are downstream impacts that we don't necessarily even think about. If we're using, a climate model to maybe, make predictions about extreme weather, and maybe, drive priorities in how we deal with extreme weather, maybe, drive resources even, we want to make sure that that's happening fairly, right? We want to make sure that our model is performing well for everyone, so that we can allocate resources appropriately if that's what this model is doing.
Sarah, one more question for you.
Sure.
Mary says in the chat, what tools are used for monitoring and drift?
Yeah, sure. So there's a number of tools that are used. A lot of them are sort of enterprise level tools. So that's kind of why I mentioned it's difficult to do monitoring, at least in an easy way. If it's kind of just you setting it up on your own, I think there might be a few things, and I can actually, I'll add some links in the Collab too after the talk that kind of has some of those. There are a few tools that I've seen that are open source. They're not quite as easy to use. But one of the things that I recommend, if you're just trying to kind of look at things, the way that people do this is they compare the distributions of their training data with their new inference data. So it's really just looking at differences in distribution. So you can use tools from SciPy, really anything that can compare sort of the, comparing matrices is essentially what you're doing, right? You're comparing two distributions. So there's a number of tools for doing things like that you can definitely use. But I'll add a few extra links actually to the Collab later. Are there any other questions or any follow-up on that one?
Oh, James, are you saying you can't unmute? Why is that happening? Let me see. You would like to unmute yourself? Hold on, let me see if I can. I'm seeing. Okay, you want to type your question in the chat? I'll see if I can rectify that problem in the meantime. Is James still in here in the room? Okay, I'm not seeing your name in the chat. I'm trying to locate your name so I can, right? Sarah, you can go on and then we'll see if we can actually rectify that problem, right?
Sounds good. Okay, yeah, so getting back to accountability, yeah, being sure to show who and what your model impacts, even sort of downstream of what the actual direct model output is. That can be really hard to do, but it is helpful. Ensuring the model treats any marginalized groups fairly. So this can, unfair models can happen even if you're not putting specific human data into the model, like we see with this climate model. So if we're talking like geographies, there's obviously a huge risk that people in sort of geographies that are sort of under-resourced can be treated badly, or even if we just don't get a lot of data from certain parts of the world, those areas can, people in those areas can be treated unfairly. And so, yeah, like I said, explaining any possible downstream impacts of your model. So really taking some responsibility for what your model is doing in the world is important, because the performance is directly tied to the ways that the model works in the world. Again, I'll get to example, and I think this is the end. Climate models can be, like we said, geographically biased based on what data is available. So what we could kind of think about what data maybe we could add to ensure that a model does work for everyone if we're concerned about bias in terms of how well it treats different places in the world. And so, yeah, I think it's worth kind of thinking about like how a climate model could impact different people across the world. And, in this talk, we're more talking about, well, how do the outputs of the model affect people and what are we doing with them? But there's also an element to like collecting the actual data that goes into this model. Are we sort of being responsible about how we're gathering data and making sure that our data is sort of accurate from different parts of the world, making sure that we've gotten consent to collect that data. So there's way more that goes into this. And we can talk about accountability and responsibility and impact in this sense for a long time, but those are the big ideas. So that's all I've got for the sort of theory part of this. Does anyone have any questions, or do we resolve the mic issue?
Yeah, I think that there are no further questions.
Okay.
I believe that we have a few persons who may need to be removed currently. So I just would like to remind persons within the talk that today's lecture is a technical talk. If there are any other issues you would like to raise out of the context of this session, you can raise that with us afterwards. So you could feel free to continue, Sarah. Thanks.
All right, sounds good. So I'm gonna stop sharing this and I'll just go into the notebook to give you guys a little bit more of a real world view of what this looks like. All right, can people see the notebook?
Yes, we can.
Awesome. Okay, so I'm not going into sort of all of the parts of the talk here, just because it covers a lot of ground. But I'll give you a few examples here to kind of get us started. So this notebook is very similar to the notebook you guys had from last session. It can even sort of be added to the end of that, but it's also a little bit separate, or it can be used separately. So I did train a model here. It's not a very complicated model, so I won't go into too much detail on that part since it's not really the focus, but I'll go through it briefly just so everyone kind of knows where we are. So I'm just loading up the same train and test data. We're not really going to be using the test data here. I'll create my own evaluation set. Same basic pre-processing here that you did in last week's session. The only difference was I just kept start date for a little bit longer because I wanted to sort my data by that date. So yeah, same pre-processing down here. I kind of arbitrarily selected a few features from the full data set just to make things a little bit simpler. I think most of these are the same ones that you used in last week's session in the notebook. So I just defined everything that I'm kind of looking at here. So my selected features, the target column, the thing I'm trying to predict here. And then I decided I want to take the first 2 years of data, 2014 to 2015, and use them sort of as my actual training data, and then use this the data from 2016 to do that evaluation that I talked about. So what I'm doing here really is making sure, again, that sort of my evaluation data set is somewhat representative of what I expect the data to look like in the real world. So since I know that I'm going to have to get my model to work well on future data, I want to test and make sure that it can generalize to future data, right? So that's what I'm doing here. And then, yeah, basically just setting this all up so that if I did choose to change it, it would be relatively easy to do. So that's the system here. And I did make use of scikit-learn's pipeline features. So if you are doing any model development sort of in a production setting, highly recommend using pipelines of some kind for this. It just helps to make sure that you don't have any data leakage, that you're kind of getting your pre-processing steps handled correctly, and that you're handling your different types of data. So the way that I set this up, most of these obviously are numerical features, and I did keep month in the data set as one of the features, and that's going to be treated as categorical. So that's what that's doing here. Yeah, so basically I defined this preprocessor through all of this. And now I'm just doing a really simple linear model, a ridge regression for this, and nothing fancy at all. But as you can see, I've kind of been able to define a pipeline where I've got a preprocessor and then my regressor here, and I'm fitting on to that. So yeah, most of this is not too relevant to today's conversation, but I did want to highlight the pipeline as a very useful tool if you're not using that now. Going on, so we can evaluate this on my entire evaluation set, just very briefly. I think this is the R squared score. So 0.92, not too bad. But let's now get into this more thorough evaluation of the model. So what I'm actually doing here is I'm creating this evaluation data frame. And what this is basically is just to make it easier for me to start plotting things and kind of looking at how this model is behaving. So I'm just creating a copy of my X evaluation data frame. I'm adding all of the predictions that I got from it to that, and then I'm adding the actual ground truth here, the Y eval. Okay, any questions so far more related to like how I did the data splitting or the model training part? All right. So the next part here, I just want to look at what the distributions are of the predicted values compared to like the ground truth values. So here the predicted values I think are blue and the ground truth is orange. So these distributions look really similar. So that's obviously promising. It's also expected since we have pretty good performance on this model. And then, of course, just to get a little bit more, and you guys did a lot of this last week, but looking at a couple different metrics. So we got the R-squared score, we've got mean squared error and mean absolute error. So just looking at all of these and making sure kind of everything is making sense. Given that the distribution looks good for both of these, I'm not too concerned about using any special types of evaluation metrics. And then since I'm a little bit worried about the geographic like different geographic spaces and how they might perform across, or how this model might perform across geographies, I'm just going to look at the distributions of latitude and longitude. So this is just from the evaluation data set. And you know, they both don't look especially interesting, but here we've got those two distributions. So I'm still kind of curious about how those are performing. So what I actually did here was I binned these variables into 5 groups, each of them. So we've just got, I just labeled them 1, 2, 3, 4, and 5, but with 1 being sort of the lowest values, and kind of this section, and 5 being over here. So I do that for both the latitude and the longitude variables, just binning these so that I have an easier way to evaluate how the model is performing on different segments of the data. And so I added that to this evaluation data frame. So this method that I'm using here of kind of creating a full evaluation, sort of almost a new data set for myself to run evaluations, is a really helpful way to kind of start even a system of tracking a model. If you've got one in production, you can sort of set up this whole system and kind of do it every time you send a new batch of inferences. So that's how I would recommend doing some of this monitoring in a real world system. If you're kind of strapped for resources and you're trying to do it on your own, I think setting up this type of evaluation data frame and kind of just running it, you know, whenever you need to is a great way to get started with this. But so here I've got the data frame. I've got these groups now that I've created for latitude and longitude. So these are at the end. And I'll be getting into kind of how we can start visualizing this here. So here I've kind of set this up. It's a little bit of code here, but nothing too crazy, to just plot how are we performing on these different longitude groups. So with the lowest longitudes are at 1 and the highest are at 5. And then of course there's the middle. So this plot kind of shows us, and it does look like there's a little bit of difference here. I guess 1, so these really low longitudes seem to be performing worse than the rest of the model. Otherwise, it's not too much difference. Maybe we'd want to see, if we were going to retrain this model, if we could add more data from this segment. That of course would be more effective if we had more access to the original data. That would be something to think about. And again, I guess I do want to highlight, this is not the best plot ever, but it is important if you're going to be reporting this to people or trying to sort of show them that they can trust this model. Make sure you use good visuals, make sure to have labels, get good at doing this. It's important, and it's worth spending time on when you're reporting your results. And so we'll look at the same thing across latitude, and it's actually much more uniform here. There's not a whole lot of difference in performance on latitude. And these are all looking at those R-squared values as the metric. Okay, so are there any questions on this section of sort of binning our longitudes and latitudes and kind of looking at performance across geographies? Okay, cool. So yeah, this is a thing, again, in an ideal world, you'd be doing this regularly, right? If your model is running in production, you'd maybe do this, every time you send a lot of inferences, or maybe on some weekly cadence, and you'd check just to see if anything is changing. There's always a chance that at some point, one of these groups suddenly starts to perform worse, and you'd want to figure out why that's happening or try to deal with that problem. And that would be an indication that there is some drift happening. And so, yeah, that's kind of what this section gets into is then monitoring performance actually over time. So the way that I set up the evaluation data set, I just took, I think it's about the last 8 months or the most recent 8 months of data. So we're trained on the older data and now evaluating this most recent 8 months. So what I did is I just created a data point here for the performance score for each each month of the new evaluation data to see if any of that is actually changing or what's going on with it. And so what I was actually expecting here when I first plotted this was that, you know, you'd have higher performance sort of in the earlier months, and then the performance might degrade a little bit over time and get worse for the later months. That's a more common thing to see. What I actually saw here was pretty interesting. It looks like we had really poor performance actually for January, February, pretty bad for March, and then things actually improved kind of in the later months. So what I think here might actually be going on is that there is poor performance on some of these winter months maybe, or for some reason a seasonal difference in performance here that we're looking at. So that would be an indication that maybe we need more data from maybe January, February, March in our when we retrain a model. Or maybe we just need to evaluate, you know, if there's some way that we can weight those higher in our you know, in our evaluations as we're sort of, or in our validations that we're kind of going through and training models. So I just put this into a bar plot to kind of look at it a little bit more closely and get these actual values. And yeah, we can see like February, the model performed at 0.55. So much worse than some of these later months. So yeah, really worthwhile sometimes to just look at your model performance on these different data segments, because you start to notice things that have gone wrong, and it's a really good way to figure out how to actually deal with that. So any questions in this section? Okay. And then the last thing, this is getting a little bit into drift, and I didn't do any drift metrics in here, but I will add some links to some of those resources. So this is just looking, is there a change of our data over time? Does the data that I put into the model actually change since we first trained the model? So looking at this, I sort of created this plot, just looking again month to month, how is the data? And I think what we're seeing here, it looks like, as expected, I guess latitude and longitude are constant. We wouldn't really expect those to change too much over time. But the rest of our values did, and it does look like it's probably mostly just a seasonal change. So that might be able to somewhat explain why we're getting differences in performance month to month. So this is the way that you might go about sort of an you know, very basic level monitoring your model's performance and seeing kind of how they're doing, and then also reporting that, right? So like once you got your model to a point where you were really confident and you were ready to put into the world, you'd want to sort of show this to whoever's making decisions or whoever you're trying to help with this model, show them any of these metrics that might be relevant, sort of prove to them that they can trust that this model will work well every month and across all of the geographies, and sort of use all of these tools, not just to, you know, be good at data science, but also to show people that they can really trust your model in production. Yeah, so that is all the material I have. Open to any questions that people have. Yeah.
Okay, great. Thank you, Sarah. That has been a very, very fruitful, really meaningful talk to kind of walk us through all the aspects we should think about when we finish training our models. I think the audience has gotten a lot of great insights, and particularly if moving from the talk and integrating with the notebook has been truly helpful. Anyone has any sort of, you have any comments or any? Right, Mary says thank you in the chat for the talk. Anyone wants to set up a discussion? We have some time now to have any sort of questions or queries you want answered based on what she spoke of here, or anything else that you want to raise with her based on your field, where you see something that maybe that you need some clarification as to how to approach it. Maybe you can ask Sarah. Anyone has anything you want to add or ask? Any comments, any questions? In the meantime, Sarah, from my end, what is the biggest challenge you face in your specific field when dealing with moving past into the real world aspect? Because I know you spoke in the climate model about like ensuring with the geographic locations and that sort of thing. like, could you give us some other examples of other, like in other fields or other areas that you encountered in your field of work? What sorts of challenges you would have faced after you trained your ML model and had to go to the real world context with the model?
Sure, yeah. So one of the things I've seen, actually quite a few customers, and these are, bigger companies, so large enterprises struggle with, is actually sort of that retraining process. So even if they've maybe identified that a model is out of date, and even if they can see that, being able to set up a system to retrain your model effectively is difficult when you're at sort of a large scale. And I think even when you're an individual, it can be hard if you're dealing with sort of updating data and keeping track of what data your model was trained on. Sort of like, it's not really the fun part of machine learning, but it's the necessary part and sort of the infrastructure part, right? Making sure that you're keeping track of the version of your model that you're using and what data it was trained on. Sometimes you might change your features, change your columns, and sort of keeping track of what you did, how the model's performing, and then what you need to update can get, just the logistics of that get really complicated. And that's what I see a lot of times as a problem. Talking about sort of more other real world use cases where models, tend to perform badly, I can talk about one example that I've seen in sort of a healthcare company where they have a lot of models that are relatively simple binary classification models. They're making predictions about whether someone is likely to develop, some condition, some medical condition, in the next year. So are they likely to, I don't know, get brain cancer within the next year, something like that. And of course, those are very, sort of the outputs of that are very sparse, right? It's going to be most people will not, and a very small number of people are positive, right? So when they train on that data, it's very, very class imbalanced. And then since they're training on this very class imbalanced data, often their models are not that good at predicting the positive values. So one of the struggles that they have then is, of course, getting those models to work well in production in the real world, and actually correctly predicting when someone is likely to develop, any particular condition. And of course, that can also change over time, as we've seen with scenarios like COVID-19, where ER visits can change drastically over time, or different types of conditions in the world, types of diseases people are getting can change over time. So all of that is moving, and the models are already a little bit struggling to even get it right from the beginning.
That makes a lot of sense, because even when I worked on a student retention model, and even as you said, to make sure that the model is predicted well, and then even the data is changing as at the onset, because with retention now you have students who by semester, even by not even semester, sometimes even on a monthly basis will drop out of the system, and to kind of capture those things, it's really like to keep up with that is a bit of a stretch sometimes. So I could see where those challenges you face with larger models would come into play. And I'm seeing Mary is also commenting, when presenting to stakeholders, do you show them your model via the Google Collab? That's one question. And then the second one is, what happens if you are using live changing data? How would you create a model that is consistent? So I don't know if you want to take them both, or let me go back from one. The first one, the one is presented to stakeholders. Do you show them your model via Google Collab?
That really depends on who the stakeholders are, right? If they're data scientists, or if they're, sort of more technical people who are used to seeing a notebook, I might use Google Colab, or maybe, some other notebook, Jupyter Notebook, a different notebook environment. But I think if it's not someone who's used to seeing this like code or a notebook environment, that can kind of scare them a little bit. They don't necessarily, unless you're used to seeing code, you don't really like to see code very much. So what I tend to do when I'm presenting to people who aren't technical in that way, I usually, create my really nice graphics in my notebook, and then I copy and paste them into, whatever format is appropriate for that audience. It's usually, a slide deck or something like that. And what was the other question?
Right, yes. And the other question was, what happens if you are using live changing data? How do you create a model that is consistent?
Yeah, if I knew the answer to that, I think I'd be doing very, very well in life right now. There's no good answer.
Yeah.
What you do is you retrain your model. There's really, I don't think there are any models that are always good when the data is changing. Maybe if you have, if you have sort of a live, like online learning model, some reinforcement learning models might be able to do some of this, since they're sort of updating online. But for most traditional sort of machine learning models, you can do your best at making a model that is robust and that generalizes well. And so that's where, using good feature engineering, good feature selection can all help to make a more robust generalizable model. And so that might require less retraining and less updating. But you're still dealing with a world that might be changing in ways that your model just can't handle, and that's not really avoidable. So really, it's keeping track of it and retraining that most people are going to be stuck with doing.
Yes, that makes a lot of sense. And she also added that I've heard that the majority of machine learning models are never deployed. What are some ways to change that statistic and the environmental training and computing resources, but in the end, never do anything with the project?
Yeah, I think there's a couple of elements to that. So I think that number, when people say most models are never deployed, I think a lot of that is because usually when people are developing models, they do a lot of experimentation, and they might even systematically train like hundreds of models and then figure out which one works best when they're doing sort of their hyperparameter tuning or their feature selection. So a lot of those models that don't go into production are just sort of people experimenting, and some of that's probably okay, but I do agree that we don't have infinite energy. We don't want to have the environmental impacts of training hundreds and hundreds of models for one or two of them to actually work and go into production. So I think ways to avoid some of that is by one, just making sure you're getting it right early, making sure you're defining the problem right, just being very careful and thoughtful and responsible as you're doing this development. In just selecting features, bringing in your domain knowledge. If you know about whatever the domain is that your model is working in, you can probably avoid doing this sort of brute force feature selection to some extent. If you just have a lot of, if you have some concept of what features are likely to be good, you should trust your own knowledge. So I think some of that can help. I think also, it's also can be diminishing returns if you overdo sort of hyperparameter searches or things like that. Sometimes they don't help improve model performance that much. So maybe minimizing some of that stuff. If you can get your model to perform good enough, sometimes that's better than a higher performing model that is really overfit, or that is just has you've run thousands and thousands of tests on, because it really just matters that the model performs well enough to do whatever it needs to do in the world. So sometimes we're in a contest, you're trying to get the best possible performance. In the real world, you need performance that's good enough to do what the model's purpose is, right? So hopefully that answered the question.
Yes, that makes a lot of sense, because I mean, we realize that especially teams working in the competition, they realize that, as they go along, sometimes they may be figuring out how to drop variables depending on certain context, it to impute something here and there. And then in the real world, it may not necessarily be the best variables for that model, depending, as you said, on the domain knowledge, whatever the client really needs, the needs of the client and the customer, the end users, as you say. So that's really great, Sarah. I mean, we really appreciate that. Anybody else has any specific questions or comments that you would like to? You have a few minutes again if you would like to jump in and add anything. All of the resources, just reminding you, all the resources today will be provided to you at the end of the session. So you can always go back to it. And Sarah herself, she is also on LinkedIn, so you can feel free to reach out to her there. On our website, you can actually navigate to her LinkedIn page. So I'll just put that in the chat. And yeah, so anybody else wants to say anything before we end off the session today? I think it has been a really, really great session, Sarah. I mean, it really, I would like to say that, you really brought everything together for the past few weeks that we have been learning about kind of going from start to finish. I think this really kind of showed us now, okay, so past, even if we're not in the competition, and a lot of you are actually in industry, how to actually make sure that we think about all the moving parts of the process, which is really key. So I am just giving persons one more chance. Let me just check the chat to see if there's anything else. So that looks like pretty much it. Let's see. So Mary says a few of them saying thanks to the workshop. So I would like to say on behalf of my team, we're really, really happy, Sarah, that you were able to join us today and give us all these great insights. It has been really, really helpful to not only myself, but also to the participants. And thank you to the participants for your joining, taking your time out of your day, night, wherever you are, to be a part of the session today. So we will keep in contact. You all feel free to reach out to us if you have any questions, comments, queries, anything. And that's it from our end. So you all take care and stay safe out there and do enjoy.
Yeah,
and
it's
Sarah,
great talking.
sorry about that, but any last words for them before we go in terms of like any advice?
Oh, advice. I don't know. I mean, yeah, if you are in a situation where you're, you're working in a company or working in a production setting, definitely worth sort of paying attention to these, these topics that I brought up, even if there isn't a system for monitoring or there isn't a system for sort of this type of cross-segment evaluation. Being the person to bring this stuff up means that you're going to be the person identifying some major problems. There's always problems with every model. So definitely worth bringing up if you're the person thinking about this. It's often a good thing for you to be the one that points it out. So don't be shy about it. But yeah, that's about it.
Excellent. Well, thank you so much for that. We really appreciate all the advice. So as I said, you all could find all the links that you need on the website, and do enjoy. And thank you again for joining us. Take care. And
thanks, everyone. Bye.
Bye.